Assalamualaikum and very good morning everyone. We already finished chapter 3. Now we will learn about three major class of chemical reactions that we cover in chapter 4. Okay, here are some subtopics that will be discussed in chapter 4, but today I will discuss a solution concentration and the role of water as a solvent. Water as a solvent, water has some properties such as it has uneven electron distribution and the molecular shape for water is band. Variety of substance can dissolve in water because water can interact strongly with its solute and often plays an active role in aqueous reactions. As we can see from this figure, we can see that water has uneven distribution of electron and the electron charge distribution in water is asymmetrical compared to H2 molecule where it have electron charge distribution is symmetrical. Okay, each bond in water is polar and the whole molecule also polar. This figure shows you how the ionic compound dissolve in water. As we can see from this figure, we can see that the blue one represents the water while the brown one represents the ionic compound. We can see that the ionic compound consists of positive and negative charge. As we know that water, it also consists positive charge and negative charge. Okay, when ionic compound dissolve in water, the negative charge, it will dissociate into positive charge and negative charge, where the negative charge will be attracted to positive charge of water. Okay, here positive charge. Okay, and while the positive the cationic charge from ionic compound will be attracted to negative charge of water molecule. As we can see from this figure, okay, we can see that the bulb in here doesn't produce light when the electrolyte only distill water. This is because distilled water doesn't conduct a current. Okay, there is no current in this medium, so that's why the bulb doesn't produce light. Okay, same with here. Okay, when the electrolyte is only a fixed solid, okay, even though it consists of charged positive and negative ions, however, it doesn't conduct a current in solid state. Okay, that's why this bulb also doesn't produce light. However, when the ionic compound dissolve in water, okay, the positive charge will move to the negative charge ion of molecule of water molecule, while negative charge will move to the positive charge of water molecule. So that's why the medium can conduct current, and that's why the bulb can produce light. Okay, let's see sample problem 4.1. These problems require us to identify which beaker best represent the compound in solution. Okay, either A, B, C or D. And second, this problem also require us to calculate total number of particles in solution if each particle represents 0.1 mole. Okay, this beaker contains strong electrolyte potassium sulfate. So you should be able to know how to write the chemical formula for potassium sulfate. Okay, from this problem, you should be able also to know how to translate the statement into chemical equation. We know that the potassium sulfate, okay, it dissolves in water and it becomes strong electrolyte. Okay, so potassium sulfate actually is a from solid. Okay, so make sure you identify the state of matter. Okay, and then when it dissolve in water, it will dissociate into potassium ion and sulfate anion. Okay, in aqueous solution. So from this chemical equation, we know that 1 mole of K2SO4 will dissociate into 2 mole of K potassium plus anion and 1 mole of sulfate anion. Okay, from the equation, we can see that there should be 2 cations for every 1 anion. Therefore, because we represent this correctly, as we can see that for every 2 cations, there should be 1 anion. Okay, next we need to find the total particles in beaker C. Okay, so here we can see that this beaker C consists of 9 particles, where 6 come from potassium ion and 3 from sulfate anion. Okay, so in order to get the number of particles, so we need to times 9 with 0.1 mole. Okay, after you get the number of mole, then we need to times with Avogadro constant. Then we will get the value of particles. Okay, sample problem 4.2, okay, require us to determine amount of mole of each ion in each solution. For example, 4.2a, okay, ammonium sulfate dissolved in water. Okay, as we know that when ionic compound dissolve in water, it will dissociate into cation and anion. Okay, so we need to write equation for the dissociation of 1 mole of each compound and use this information to calculate the actual number of mole represented by the given quantity of substance. Okay, let's see the solution. Okay, we need to write the equation for dissociation. Okay, then we can get the ammonium and sulfate, okay, cation and anion. Okay, from this equation, we can see that 2 mole of ammonium, okay, is produced, okay, from 1 mole of ammonium sulfate. How about 5 mole ammonium sulfate will produce how many mole of ammonium? Okay, so you solve this equation, then you will get this value, the mole for ammonium. Okay, next, same, you can see that from this equation for dissociation, we can see that 1 mole of sulfate produced is produced from 1 mole of ammonium sulfate. Okay, how about if 5 mole of ammonium sulfate, it will produce how many sulfate anion. So you need to write this equation like this, then solve this equation, then you will get the number of mole of sulfate. Example problem 4.2, okay, it requires you to find the number mole of CSBR first. Okay, after you get the number mole of CSBR, solving this equation, we will get the mole of cation and anion. Since from this equation we can see that 1 mole of cation, okay, uh, 1 mole of CSBR solid dissociate into 1 mole of cation and 1 mole of anion. Therefore, the number mole of cation equal to the number mole of anion. Okay, 4.2c. Okay, first we need to write the equation for dissociation. Okay, the dissociation of ionic compound in water will produce cation and anion like this. Okay, 1 mole of copper nitrate, okay, it consists of 6.022 10 to the power 10 50 formula unit. How about if 7.42 10 to the power 22 formula unit copper nitrate, it will produce how many moles? So solving this equation, you will get this amount of mole for copper nitrate. Then what you need, then we need to calculate the mole of cation and anion. As we can see from this equation, 1 mole of copper nitrate, okay, dissociate into 1 mole of cation and 2 mole of anion. Okay, therefore the mole of cation equal to the mole of copper nitrate. Okay, and since the anion, okay, the number of this 1 mole of copper nitrate solid dissociate into 2 mole of nitrate. So that's why we need to sign with 2 to get the mole of nitrate ion. Okay, as we know that we can express the concentration using molarity. Okay, the equation for molarity is mole solute per liter of solution. Okay, the unit is moles per liter. Okay, let's see the sample problem 4.3. We need to find the molarity that contains 0.715 mole of glycine in 4.9 ml. Okay, so very straightforward question. So you have mole, so you also have volume, so you can divide mole with the volume, then you will get the molarity for glycine, which is 1.44. Okay, this is summary between mole, mass, volume, and entity of substance in solution. Okay, if we get mole, okay, is already know the mole of substance, so we can get the volume of solution. We also can get the mass of substance, okay, and we also can know entities of substance in solution, okay, but make sure we know the molar mass, okay, and molarity of the substance. Then we can get the volume and mass. Okay, sample problem 4.4 require you to find the mass of solute, okay, given the concentration of the solution and volume of the solution. So, what you need to do from the concentration and volume, you can find the mole of solute. Then you need to multiply with molar mass of the solute to get the mass of solute. So make sure you know how to write the chemical formula for sodium monohydrogen phosphate, so that you will get the molar mass for the solute correctly. Okay. Okay, so given volume and molarity, then you will get the mole for the solute. Then what you need to do, you need to, after you get the mole, you need to times with the molar mass of the solute, then you will get the mass of the solute.